what exactly are fractions, how can we play with fractions, and how usually we convert decimals to fractions. This is what we will discuss today. Okay, so first thing first, let's start. What is a fraction? It is basically a expressed as a ratio of two integers, a or b, right? And this can be represented in decimal form, for example, in w.xyz, right? And this is numerator. This is numerator and this is denominator. And this is in terms of decimals. This is decimal point. These are fraction values, and on the left side we have a real value. We have a whole number, right? Okay. So what we are exactly meant by a fraction? Let's suppose we have a pie, and for example, if we divide into 4 parts, and if I ask to pick one part out of 4, right? So I am picking one part, and as a whole there are 4 parts. So right, for fraction what I pick is 1 out of 4. So you can say that it is just like part over total, right? Okay, so if we try to see these in the number line, it was 0, 0, 0, 1 on the right side we have greater than 1, -1 on the left side we have less than -1, right? So remember, there are infinite fractions between any two integers. There are infinite fractions between any two integers, right? If let's suppose we have the fraction in between range of 0 to 1, that could be 1/2, 1/3. And if that is greater than 1, that will be, let's suppose, 3/2 and 5/4, right? And likewise, these could be negative as well. Okay, so for example, we have a fraction a and b, and what sort of operation we can do? I'm not asking about the overall operation, addition, subtraction, but for example, I'm saying that we can multiply and divide by same value for both a and b, for the numerator and denominator. For example, if we multiply with 2 on the numerator and 2 on denominator, the result will be same. If we divide by 2 and if we also divide b by 2, the result is also same, right? But if I add 2 in the a and if I add 2 in the b, the result will not be the same. Likewise, if I subtract from a and from b, the result will also not be the same, right? For timing, I'm just giving an idea. We'll discuss each of these a bit later. Okay, so basically there are 3 types of fractions. First one is proper fraction. Second one is improper fraction. And the last one is mixed fraction. If our value of the fraction lie between 0 and 1, if this is in the range of 0 and 1, such fraction will be proper fraction. For example, we have 1/2, 2/3, 3/4. So for in this case, our denominator must be greater than the numerator, right? This is the first type of fraction. All you need to know the what is the definition and what TR. They GRE don't especially ask about these, whether these are proper fraction or improper fraction. I'm just giving an idea about the fraction. For improper fraction, if we have a value greater than 1, right? For example, we have 3/2, we have 4/3, we have 5/4, right? In these cases, our numerator is greater than denominator. So this is the improper fraction. Okay, third one is mixed fraction. A mixed fraction consists of integer as well as the fraction part. For example, we have 5/2. We can also write this as 1 plus 1/2 plus 2, right? If I solve this, this will be straightforward. take the LCM, this is 1 plus 2 into 2, which is again 5 by 2, right? So if I try to convert this into a mixed fraction, I will do this way: 4 plus 1 divided by 2, a multiple of this. So this will be 2 plus 1 by 2. And I can write this as 2, 1 by 2. This is the whole number part, the integer part, and this is the fraction part. Okay, till now, is there any confusion? This is just a brief intro.
No.
No confusion.
Okay, so let's have only one question. Is this visible to all?
Yes.
Yes.
Okay, try to solve this question, but don't use the calculator. Just solve this question. Okay, so first, what's the answer of this question? Any answer?
Probably quantity B is greater.
Quantity B. Okay, so one answer is quantity B. Any other answer? Please don't use a calculator. Because I just wanted to show that how the question could be asked and how you can solve that quickly instead of using a calculator. No other answer?
See?
Oh, I see. Okay. So usually there's always a pattern in this type of question, which at first sight seems a bit difficult. If you see closely, denominator is 1.0002, right? Okay, so can we write the upper side as 1.0002 minus
A is bigger.
0.0003? Isn't this the same as the numerator?
I think so. Both are same. Yeah.
Okay, listen, wait. I'm saying that try to see and try to form a pattern out of this, right? See that here denominator is 1.0002, right? And in any case, if we have a same denominator, same value as denominator in the numerator, this question could be made easy, right? So think this way, that if I make this thing out of this, for example, I can write this as 1.0002 minus 0.0003. The result is same as 0.9. Am I right?
Yes.
Yes.
Okay.
Yes.
If I proceed further, this will be 1.0002 over 1.0002 minus 0.0003 divided by 1.0002. So these are same. The result is 1. So this will be 1 minus this value, right? 0.0003. 0.0003 divided by 1.0002, right? So just keep this for time being. Now let's move to the B part, and we can also write in the same way as 1.0001 minus 0.00003 divided by 1.0001, right? And if I proceed further, this will be 1.0001 divided by 1.0001 and minus 0.0003 over 1.0001, right? This will become 1, and this will be 1 minus 0.003 over 1.0001. So everything is okay till now? Yes or no?
Yeah.
Yes.
A is bigger. Yeah.
Okay.
Yes.
I will clear the screen and I will proceed. Okay, so now one is quantity A and one is quantity B. And quantity A is 1 minus 0.0003 divided by 1.0002, and B is 1 minus 0.0003 divided by 1.0001, right? I just write this in form of the. Now, in quantity comparison question, the quickest way is just consider these as two sides of inequalities, right? So you can perform addition and subtraction on both sides, right? Now, if I subtract -1 from both sides, if I add -1 on both sides, -1 and -1, right? So 1 will cancel out, right? So we are left with minus 0.0003 divided by 1.0002, and this is minus 0.0003 divided by 1.0001, right?
We just subtract -1. I mean, subtract 1 on
One
both
from both
quantities.
sides, right? Yeah. Now,
If we need to subtract, then don't we need to add? I mean, if we add something at the same time, we need to subtract the same quantity, right?
whatever you do, addition or subtraction on this side, you have to do same on the other side. And I subtracted 1 here, likewise also subtracted 1 on the other side. Okay, so now we can divide by 0.0003 on both sides. 0.0003 and 0.0003. So this will cancel out, and we are left with -1 over 1.0002 and -1 over 1.0001. And if I cross multiply these, right, so this will be -1.0001 and this will be -1.0002. So now can anyone of you tell which of the following quantity is greater, A or B?
-1.0001.
Yes.
A, quantity A.
Quantity A is greater.
A is bigger.
So you got the point. What exactly I done? I just did in this question.
Yes, got
Yes.
it.
Yes.
I
Then sir,
have a
in
question.
shortcut, how could we understand?
This is shortcut. I just explained in a way that you felt this is a long method, but this is just a shortcut method. And when I solved myself, I hardly took 5 seconds or 10 seconds to solve this question. This is a very shortcut method.
Okay.
In this question, just try to form the pattern, and the question can be solved very quickly. And if you start using calculator for this, to be honest, the first few values after decimals are same in both of these. So someone might get confused and just use option C. So that's why it is better for these type of questions to directly use the any pattern sort of way, not exactly use the calculator, on-screen calculator, right? So now what was your question?
I had this question that can we put like a quantity A and quantity B equals, like did you like
No.
you cross multiply
Listen.
them?
this is same as the inequality, right? Inequality. In inequalities, if you know that your number is positive, for example, we have 1, 2, we have 3, 4, we can cross multiply. But in case we are unsure, we have some variable, and for variable could be negative, could be positive. If the variable is negative, if first consider positive, in that case you cross multiply, there is no change in the sign. If this is greater, this is same greater, and if it is small, it will remain the small. But if the variable is negative and you cross multiply, the sign will inverse, the sign will change. That's why whenever you consider a quantity comparison, you are actually, this is a mirroring technique. You just consider these as the two sides of inequalities and you just solve. But remember, in case of variable, when you are unsure whether that is positive or negative, never multiply or divide with the same variable. You can add or subtract, but you can never multiply or divide the same variable. Got my point?
Okay. Yes.
Okay, perfect. So now let's play with the fraction part. Okay, for example, we have a fraction a over b. Now let's build up some scenarios out of this. First scenario is, let's suppose b is greater than a, right? So our a over b is less than 1, right? Because our denominator is greater, this is proper fraction, and our result is less than 1. Okay, so give some values to a, b. Let's suppose this is 2 and this is 3, right? And if I add some positive integers, same positive integer to a and b, for example, let's call that integer as x, and for example, if I call that as 2, right? So a plus x over b plus x is equal to 2 plus 2 divided by 3 plus 2 is equal to 4 by 5, right? Now tell whether a over b is greater or a plus x over b plus x is greater. Which quantity is greater? A over b is 2 by 3 and a plus x over b plus x is equal to 4 by 5. So which quantity is greater?
A by
A
B.
plus x upon b plus
Both-
x will be greater. 4 by
4
5.
by 5.
Won't both be equal?
No.
4 over 5. 4
A
over
is
5
greater.
is
Listen. I
4 over
told
5
you
is
one
greater.
thing earlier in some earlier session, that in when you are just comparing two fractions, for example, this is 2 by 3 and this is 4 by 5, just cross multiply these. So this will become 5 into 2 and this will become 4 into 3. So this is 10 and this is 12. That's why 4 over 5 fraction is greater, right?
5.
And here 4 over 5 fraction is a plus or b plus x. So that's why this is greater. So just remember this scenario in which we have a proper fraction and same positive integer is added in both. The result will be greater than the actual fraction which we are given earlier, right? But likewise, if I subtract same, variable from the a or b fraction, so for example, this will become 0. Let's change the value of x. For example, for time being, x is 1, right? Because 2 minus 2 will become 0. Let's change the values. So this is 2 minus 1 over 3 minus 1, right? So this will be 1 over 2. Now tell, and a over b is equal to 2 by 3. So tell a over b is greater or a minus s over b minus x is greater. Which quantity is greater?
A over B is greater.
Yes, a over b is greater. A over b is greater than a minus x over b minus x. So these are first two scenarios for the proper fraction. Now let's move to the improper fraction. For improper fraction, our a over b will be greater than 1, right? So let's consider a as 4 and b as 3, right? So again, let's consider a positive integer 2. And if I add x in all of these, in both a and b, so this will be 4 plus 2 and this will be 3 plus 2, right? So this will be 6 by 5. Now tell a over b is greater or a plus x over b plus x is greater.
4 over 3. A over
Yes.
B.
In this case, a over b is greater than b plus x, right? Okay, so one last case in which we are subtracting the same positive integer from both a and b, right? So a minus x over b minus x is equal to 4 minus 2 over 3 minus 2. This is 2 by 1, right? And 2 by 1 is greater or 4 by 3 is greater? Straightforward, this is greater, right? So in this scenario, a minus x over b minus x is greater than a over b, right? So basically, we have come up with 4 scenarios, right? And we have a over b. And in first case, b is greater than a. In other case, a is greater than b. And we have a plus x over b plus x and a minus x over b minus x, right? In first scenario, a plus x over b plus x is greater than a over b, right? But in this scenario, a over b is greater than a plus x over b plus x, right? And in this scenario, a minus x over b minus x is less than a over b. Let's do this. And in this scenario, a over b is less than a minus x over b minus x, right? I just told you this whole scenario because I have seen plenty of questions just using the same concept, right? Just see one question and you will at least, try solve this question now. Or you can solve this question very quickly.
And we say
E.
D.
G.
D.
Okay,
Okay, now
now you can clearly identify that the answer to this is D. Because there are 2 scenarios. A over B is less than 1 and A over B is greater than 1, right? So in one scenario, A is greater than B, in another scenario, B is greater than A, right? Like my same question could be asked for A minus C and B minus C, right?
Also D.
So in that case, also answer will be also D. But if they restrict that, let's suppose A over B is less than 1 or A over B is greater than 1, then you will have to see that which quantity is greater, right? Okay, this is pretty much common concept, right? So just be clear with this. Okay, so next thing is very interesting, and that is conversion of decimals to fraction. And okay, just wait for a second. Okay, so what are exactly decimals? For example, we have a dot b c, right? This is decimal point. This is the integer part, and this is the fraction part. And in decimal portion, we usually see only 2 types. One is terminating decimals, and the other one is recurring or repeating decimals. And this is a topic that most of us usually fear about. Okay, so let's see both of these in detail. First one is terminating decimals. Or terminating fraction. Okay. First of all, let's suppose we have fraction. Remember, in case of terminating decimals, always, and in case of even in the recurring decimal, always first reduce the whole fraction into in least form. For example, you have 2 by 20. You cannot say anything unless you first reduce it to 1 by 10. Now you can say whether that is the recurring or whether that is a terminating, right? So first thing is you have to just reduce them into their least form, right? Okay, the first thing, one, you have the reduce this into your least form. The fraction can be called as terminating if and only the denominator is in the form of b is actually denominator is in the form of 2 and 5n, right? Where n is where n and m are non-negative integers. For example, we have 1 by 2, we have 1 by 5, we have 1 by 2 into 5. So in actual, the decimal will terminate. This will be 0.5, this will be 0.2, this will be 0.1. In any other case, when you have any other value except 2 and 5, the fraction will not terminate, right? For example, take another value. If this is 1 over 3, this will keep on going to infinite times, right? So for terminating, the denominator must be a multiple of 2 and 5. This could be either 2, any multiple of 2, any multiple of 5, and any combined multiple of 2 and 5, right? Okay, well, first of all, one more thing. You must know what is 1 by 2, what is 1 by 3, what is 1 by 4 till 1 by 11 at least. So what is 1 by 2?
0.5.
0.5.
What is 1 by 3?
0.333.
Okay, so usually we'll present this as bar, or we can also represent as a bracket around this, right? This is one and the same thing. 3 is just the recurring part, and we keep on moving to infinite time. So what is 1 by 4?
0.25.
0.25. So what is 1 by 5?
0.2.
2.2.
0.2. What is 1 by 6?
0.16.
0.16. 6 with goal alone, right? What is 1 by 7? This is approximate. If you go for approximation, this is 0.14. But in actual, this is the what can I say? This is the recurring fraction decimal, and this has some pattern 1/4 something. That is, but exactly you don't know, don't need to know all of these. But you just at least this is 0.14 approximately, right? Okay, so what is 1 by 8?
0.125.
What is 1 by 9?
0.1.
0.1.
0.1111.
Right? And 1 by 10 is very simple, 0.1. And what is 1 by 11? 0.090909.
0.0909.
Right? Okay. You should know these till 1 by 11. Right? If you know any one of these, you know 1 over 2. So you can make for 3 by 2. You can make for 5 by 2, right? Please mute yourself. Who is available?
তো আমি যখন আমার কাছে শুনছিলাম, আমার বলছিল সে অফিসারে ঢুকছে, আর কিছুদিন আগে সে স্ট্যাটাস দিল যে সে এখন 6 গ্রেডে বেতন পাচ্ছে।
Okay, let's move forward now. Let's have a question and solve this question now. We have just 1.5 minutes for this question, and then we'll proceed further.
B. Oh, sorry, indicate also.
All.
Okay.
All.
Okay, so what's the answer?
I think it's a B.
All.
Okay, so one answer is all. Any other answer?
It's a B. All except B.
Except D.
All. And next one is all except
Except B.
Except D. Except
D.
D.
Okay. Any other answer?
Except B.
Okay, except B as well. Okay, so let's solve this question now. First 6 by 80, right? So we can write, just first convert this into least fraction. This is 2 by 3 and this is 2 by 40. This will cancel out. And this is, I told you just for 0, just make 2 into 5. So 4 into 2 into 5 and 4 is 2 square, right? So this is 3 over 2 cube into 5. It is multiple of 2 and 5. That's why this one must be a terminating fraction. This is possible. Now let's move to the second one. And remember, if you earlier don't convert this into the least form, you might have got this wrong. Because what exactly is 231? That is 3 into 77, right? And what is 4? This is 48 into 2 into 5 for 0, right? And the 448, this is 2 cube into 3, 2 4 into 3. Yes, 2 4 into 3.
Yes,
Right.
2 4 into 3.
Now 3 and 3 will cancel out. So in upper part we have 77 and lower there are just multiple of 2 and 5. Any multiple doesn't matter. So this is also a terminating fraction. Right? Okay, so someone is saying the answer is 6. Okay, one answer is 6. Any other answer? Okay, let's solve this question now. First of all, we have this fraction and the question is that it's expressed as a terminating decimal, right? How many non-zero digits will the decimal have?
2.
Now, okay. 2. Okay, now let's try to form some pattern in this. Okay, we have 1 divided by 2, 11 into 5, 17, right? In any way, if we have 10 in denominator, our calculation will be very simple. How can we do that? I told you earlier that in case of fraction, we can multiply with same number and also divide with same number. Okay, if we multiply and divide with 2 power 6, 2 power 6 into 2 power 11 into 5 power 17. This will be 2 power 6 divided by 2 power 17 into 5 power 17. This is 2 power 6 over divided by 10. We could write this as 5 into 2 whole power 17, right? And this will be 2 power 6 over 10 power 17. And we have positive power. If we move this upward numerator side, this will be 2 power 6 into 10 power minus 17. Now the result of this will be 0. The length of whatever the length of zeros, leave that. The question is saying how many non-zero digits. So what is the possible value for 2 power 6? What is 2 power 6? This must be in your fingertips now. 2, 4,
64.
8, 16, 32, 64. You must know at least 4 to 6.
64.
64, right? So result is 64 into 10 power minus 17. The result of this all will be zeros. And we have only two non-zero digits, which are 6 and 4. That's why the answer is 2. Got the point?
Yes.
Can you explain the last one, 2 raised 64 after that last?
Okay, so I believe you have understood till this point.
Yes, yes.
You already understood why I multiplied with 2 power 6 and on the numerator
Yes,
and
that all
denominator.
I got. 2 raised to
This is
16
2
by 10
power
raised to
17.
17. Till that I got.
Right. This is 2 power 6 and this is 10 power 17. Right. The result of this will always be 0. For example, 1 by 10 is 0.1 and 1 by 100 is 0.01. Right. So for these result is 0. Only we have this non-zero portion, that is 2 power 6, which is 64. So result will be 0.0 something something up to 64. Right? And we have only two non-zero digits. That's why the answer to this question is B.
Yes, I got it.
Okay, okay.
Okay. So next thing is very interesting. That is recurring or repeating decimals. Okay, so there are basically two ways to deal with this question. One is we will discuss both ways. One is the conventional way and the other method, which I usually call a quick method. You will see both of that. Okay, so let's get started with the recurring or the repeating decimal, right? This is such decimal in which we have some periodic pattern and in which the decimals number proceed forever. For example, we have 0.3333, which is actually 1/3, right? 3 will goes on and on. This can also be written as 0.3 bar on 3. We can also be written as 0.3, right? All of these are having same thing. All of these are just a different way to write this. Okay, so let's suppose if I want to convert a recurring decimal to a fraction. For example, we have some variable 0.888 up to so on, and I write this as 0. bar on number 8, right? So how can I convert this thing into a fraction form, into this form, right? Anyone of you know this method?
By
I
9
know the
digits.
conceptual method.
Multiply with the 10 because we have 10. I mean, one digit.
Okay, so let's start with the conventional method. We have x is equal to 0.8 bar, and I multiply this with 10 because I want same repeating one time on the left side of the decimal point, right? So this will be 8.8 bar because on the right side you will have still infinite values. I just do this because I want to cancel out the right portion of both. So if I subtract 1 from 2, so this will be 10x minus x is equal to 8.8 bar minus 0.8 bar. So this will cancel out and we are left with 9x is equal to 8 and x is equal to 9 by 8, 8 by 9. This is a very simple question, right? So that's why the calculation to this is very simple. Now let's increase the difficulty of this. For example, if I call x is equal to 2.8 bar, right? Now again, I have to multiply with 10 because I want the repeating digit on the left side of the decimal point as well. So 10x is equal to 28.8 bar, right? And if I subtract these, this will be 10x minus x is equal to 28.8 bar minus 2.8 bar. So this will be 9x is equal to 26 and x will be 26 by 9. Right. Now let's actually increase the difficulty level a bit more. And for example, we have x is equal to 1.234 and only 4 is the repeating part, right? Now can anyone have 10? How can I solve this question using same method? Anyone of you can explain that part?
Can we multiply by 1,000?
Multiply by 100.
Because
1,000,
whatever we
1,000.
want to do, we want to have a only repeated pattern on the repeating this portion on the right side of the decimal point. So first of all, if I multiply this with 1,000, this will become 1234.34 bar. This is first thing. And if I multiply this with 10, this will become 10x is equal to 12.34 bar. Right? At first, I multiplied with 1,000 so that I can get the only repeated pattern on the right side. And next time I multiply with 10. So again, I am having a repeated pattern on the right side. Now if I subtract this, this is 1000x minus 10x is equal to 1234.34 minus 12.34, right? And this will be 1.34 minus 12, and this is 990x, right? So x is something like 1222 over 990, right? And you can even reduce this further up till you need, right? So isn't these are a big lengthy methods to solve the way we convert these into fractions, decimal into fraction? Isn't these a bit lengthy methods? Now let's
Yes.
try the quick way. Those are exactly same, but okay, let me show you example. First of all, we have x is equal to 0.8 bar, right? So first of all, the question type in which we have only the repeating portion, right? You have only repeating portion, right? On the right side of the decimal point. Just remove the decimal point. This will be 8, and we will divide by 9 times the length of the repeating part. In this question, we have only 1 8. That's why we divide with only 1 time 9. In case if we are having, let's suppose 0.89 and both are repeating, we have to divide 9 by 2 times 9. The multiplication of 9 will depend on the length of the repeating portion, right? In first case, we have only one repeating 8. That's why we divide with 1 time 9. In second case, we have 2 repeating values, digits. That's why we divide by 2 times 9. In case, let's suppose we have 3 times 8, 9, 7. Let's suppose this will be 897 divided by 999.
999. Yes.
Right?
999.
Okay.
999.
This is a very basic case. The other case is when we have a combination of repeating and non-repeating part. For example, we have 0.123 and only 2 3s the repeated portion, right? In such question, how can we proceed?
1 to 2 by 990. 1 to 2 by 990.
990.
Yes, so that
Yes,
will be
1,
total
2.
value 1, 2, 3 minus
Plus
non-repeated value 1, and we will divide this by, first of all, 9. How many times? We have 2 repeated, so 9 2 times. And for each non-repeated value digit, there will be 1 times 0. We have only one non-repeated, that's why we have 1 times 0. So this will be 1, 2, 2 divided by 990. For example, if I just mold this question to 0.1234 and I have only bar over 34. So how can we do this? Total 1, 2, 3, 4 minus non-repeated 12 divided by how many times 9?
Minus
2 times,
12.
because 2 times into how many non-repeated digits? 2.
100.
10 into 10,
9900.
right? So whatever the result is, that will be whatever the value is 9900. Whatever the value is, that will be 1, 2, 2, 2, right? Isn't this a very quick method to solve this question? Now in
Yes.
exam, you will hardly get such easier question in which you are directly asked to convert this decimal into fraction, this decimal into fraction. Just to give you an idea that your voice is getting down. Okay, am I audible to all right?
Yes,
Yes.
you are audible.
Okay, please mute yourselves. Your voice is confusing. Okay, so let's suppose I have a situation. I have a 3-digit.
Can you please repeat that trick again? Just like quickly give an overview, please.
Okay, in case of only the repeating portion, the repeated value, right? Just that value divided by 9, and the length of 9 will be equal to the length of the repeating value. If that is 1, this is 9. If that is let's suppose 2 times, this is 9. If that is 3 times, this is 999, right? So length of 9 will depend upon the cycle of the repeating pattern, right? And in another case, let's suppose we have 1, 2, 3, 4. Only 3, 4 is the repeating pattern, right? So in that case, that will be total value minus non-repeated value 12 divided by 2. We have 2 repeating decimals, right? 3, 4. So 2 times 9 into, for each non-repeated decimal, that will be 1 times 10. Or there are 2 decimals, that's why 2 times 10, right? So this is whatever the value divided by 9900, right? 9 for each repeating pattern and 1 0 of 10 for each non-repeating pattern. All right.
Yes, thank you.
Okay, so now the question, let's make a question. For example, we have some, let me go to the question. And we have, yeah, we have this question. Try to solve this question. This is a very interesting question.
Answer D.
Maybe answer D.
Okay, so everyone is coming with the answer D. So what's the logic behind having an answer D?
We don't know the value of x, y, z.
A can be both negative and positive.
First of all, how could a value on the right side of the
Both
decimal
negative and
point
positive.
could be negative?
2 positive, 3 positive, sorry,
This
2
is
negative,
0
1
point.
positive.
Listen, this is 0 point something. How could a value on the right side of the decimal point could be negative? First of all, tell me this thing.
Is A the answer?
If x and y are negative and z positive,
I'm
then it can be
start from this thing. We have 0 point x, y, z. How could a value on the right side decimal point a negative value? This can't be a negative value. First of all, this thing. Second thing, first, we have x, y, and z all are different integers, and such that 0 point x, y, z.
okay, got it. Yes,
And
yes.
Will be
Yes,
D
was it.
maybe.
okay, just hold on. We have 0 point x, y, z equal to 1 by a, right? So question asked about a. So
It should be
in
B,
such
right?
what you are saying?
So it will be XYZ over
It will be B,
999.
right?
Okay, let's see what the answer is. Just hold for a second. Okay, so whenever you are dealing with variables on both sides, in such cases, always try to come up with maximum and minimum value, because we cannot
A is greater.
find the exact value. So in that scenario, just find the minimum and maximum value. So let's see in what case we have minimum value for this, in what case we have maximum value for this. So first, invert scenario, we have minimum value for this. First scenario, right? Minimum scenario for this. We have minimum, first of all, x, y, and z are different integers, right? So this could be, x could be 0, y could be 1, and z could be 2. Only in that scenario, the result of this conversion to fraction is minimum, right? For example, that is 0, 1, 2 bar, right? So in this case will be 0, 1, 2 divided by 9, 9, and 9, right? So in that case, 12 by 999 is equal to 1 by a, and a is equal to 999 divided by 12.
Yes, we will get a equal to 999 always. Okay, all the time we will get a equal to 999, I think.
Or in the case, that is only the case when we are having the only the repeated pattern. Let's suppose if we don't have the bar over x, then what will you do? So the answer for this is 83 point something, right? Now let's see the other scenario and try to get a maximum value for x, y, z. How that is possible? If x is 9,
Yes.
y is 8, and z is 7, right? So 0.987, this is 987 divided by 999 is equal to 1 by a, and a is equal to 999 divided by 987. This is one value like 1 point something, 1 point something, whatever the value. So our value for a lies between 1 point something and 83 point something. And whatever the answer is D, because the value provided is 80, and that is between in this range. That's why the result of this is D. So the first takeaway from this question is, whenever you are dealing with variables, always try to come up with minimum and maximum case. Because for variable, we can never come up with the exact case unless and until we are provided with certain conditions. Okay, so everyone got this question?
Yes.
And if you try to solve this question using a conventional way, that will take a lot of your time. So try to use the efficient way in all of these questions, right? Okay. Let's move to the next question. Okay, try to solve this question. This is again a very simple question.
Answer is B.
Answer is
B. B.
B or D?
B. B. B.
Okay, so one answer is B. This is very simple question. We have 0 point A, B is repeating. And next thing is A and B are different positive integers. Just keep in mind, right? Positive
0
integers. So positive, right? 1, 2, 3, up to so on. And A plus B is equal to 4. So how can we come up with the 4? If this is 1, this is 3.
1.
This is 2, this is 2, and this is 3, this is 1. This is
Yes.
possible. This is not possible
2
because
and
both
2.
are different.
2 and 2 won't be the case because
Yes, exactly.
they said different positive integers.
So we have only two cases, 1, 3, and 3, 1. Right?
4, 4.
So now 1 is 0.31 and 1 is 0.13. Right? Just open this. This is 31 by 99 and this is 13 by 99. Right?
Yes.
44 by 99.
Just add these, that will be 44 over 99. And quantity B is 45 by 99, that is definitely greater than A.
Better than, yes.
Greater than, yes, B.
Okay. Okay. for this question, because you might in this question, because we are having denominator 99, 999 and tetra 9 in some cases, always better to remember the prime factorization of this. This is 3 square into 11, right? For this, this is 3 cube into 37, and for this, this is 3 square into 11 into 101. At least you should know the prime factorization of 99, 999 and tetra 9. Because one summer told me there were question, and in that question of the recurring decimal, they have to prime factorize first, and using the calculator in the time constraint, you won't be able to do so. That's why it is better to just remember at least these three, not more than that. I don't think so that will ask you a question having the 9 having the length of 5. That will be difficult to solve in a time constraint. So at least just remember these three for exam point of view, right?
What is the last one? 3 square into multiplying 11 into 109 or
101.
Into
101.
101.
Perfect. Got this?
Yes.
Yes.
So this was all for today. I just gave just a bit intro, and just we move forward to the